Hi, welcome to another video. Today we're going to be looking at compound interest and how we calculate compound interest using what's called a repeated percentage change. So percentage change is when we increase or we decrease an amount by a percentage, and then repeated means that we're doing that repeatedly. So in the case of compound interest, we might be doing that over 2 years, 3 years, 4 years, 5 years. Right, quick recap then about the idea of calculating percentages using what we call a multiplier. So a multiplier can be used to either increase or decrease an amount by a percentage. So for example, if we want to increase an amount by 25%, then we use the multiplier 1.25. And what we're doing there is by multiplying by 1.25, we are finding 125% of the number, which explains why that works, because if we increase by 25%, or if we start with 100% and then we increase it by 25%, we're now left with 125%. Right, let's look at some examples of that then. So if I want to increase £480 by 22% using a multiplier, then I do 480 multiplied by 1.22, because if I start with 100% and I add on 22%, that leaves me with 122%, and 122% as a decimal is 1.22. So here the calculation is just as important as the answer, but the answer would be £585.60. Question 2 then. So this time we're increasing only by 7%. So again, if you start with 100% and you increase by 7%, that means that you're now left with 107%. So here my multiplier would be 1.07. So the calculation would be 72,000 times 1.07. So £77,040. Lastly, if we're going to increase by 1.2%, so if I've got 100% and I add on 1.2%, that means I now have 101.2%. Now as a decimal, that's going to be 1.012. So really important we get that multiplier right, 1.012. So 95,000 times by 1.012. Again, working out the answer is almost the easy bit. So that gives me £9,614. Right, 3 questions for you to have a go at them. So pause the video and then have a go at these questions. Okay, hopefully by now that you've had a go at those questions, I'm just going to quickly run you through the answers. So if we want to increase by 38%, then we've now got 138%. So my calculation would be 22,500 times by 1.38. Just take care putting that into your calculator. You don't want to mistype something and get the wrong answer. So we've got 31,050. Question 2, if I'm increasing by 9%, that means I now have 109%. So my calculation, 15,500 times by 1.09. 16,895. Lastly, If I'm increasing by 3.3%, that means I have 103.3%, which as a decimal is 1.033. Now, if you ever can't remember how we turn a percentage into a decimal, all I do is divide that by 100. So once you've got your percentage, you can divide by 100 and that will turn it into the decimal. So here my calculation, 4,200 times by 1.033. So that will give me 4,338 pounds and 60p. Right, moving on then. So remember, the purpose of this video was to look at how we solve compound interest questions. So a man invests 3,500 in a bank. The bank give him 2.3% interest on his money. How much money will he have after the interest has been added? So similar question to what we've just done, but it's now put into a context. So the man invests 3,500. He gets 2.3% interest, and what we want to know is how much money will he have after the interest has been added. Okay, so pause the video, have a go at that question. All right, so the bank is giving this man an extra 2.3% on top of the money he put in. So if we start with 100% and we add on 2.3%, that means we now have 102.3%. So my multiplier here is going to be 1.023. That is the most important bit. That's the bit that we've got to get spot on. So 102.3% as a decimal is 1.023. So my calculation, 3,500 times by 1.023. And that gives me £3,580 and 50 pence. Right, let's try and apply all that knowledge now to a compound interest question. So a compound interest question is similar to what we've just looked at, but rather than the person getting money for just maybe 1 year, they're getting the interest for 2 years, 3 years, 4 years, 5 years. So here we've got Tim invests £6,000. The savings account pays compound interest of 1.8% interest each year. Calculate how much money Tim will have after 3 years. So this particular bank, this particular savings account is giving Tim an extra 1.8% on top of what he invests. So remember, we start with our 100%. If I add on 1.8% to that, that is going to give me 101.8%. Now remember, what we want is our decimal multiplier. So as a decimal, that is 1.018. Again, if you can't remember how to turn a percentage into a decimal, we divide by 100. So this is my decimal multiplier. So Tim starts with £6,000 and the bank are giving an extra 1.8%, so we can multiply that by 1.018. Now, if we wanted to work out how much Tim had after 1 year, that's the calculation we do. But what we want is after 3 years. So we need to multiply that number by 1.018 again, and that will give me 2 years, and then by 1.018 again for 3 years. So you can see I'm using this multiplier, I'm using it 3 times because the question asks after 3 years. So again, be really careful typing this on your calculator. It's really easy to get a decimal place wrong. Now, chances are your calculator will give you a big long decimal. Because we're talking about money, I'm going to round that to £6,329, and then it will become 87p. I'm going to ignore everything after that because we're talking about money. So 6329.87. Okay, your turn now then. So have a read of this question, highlight the key bits of information, and then have a go at that question. Right, this time we've got Alice invests 4,500. The savings account pays her 2.3% interest each year. And we want to know how much will Alice have after 4 years. So in the example we did 3 years, here we're doing 4 years. So again, let's work out our multiplier. So if we start with 100%, if I add on 2.3%, that is 102.3%. As a decimal, that's 1.023. So that is my decimal multiplier. So the calculation then, she starts with 4,500. The bank give her an extra 2.3%, an extra 2.3% again, and again, and again. So I've done that 4 times because the question asked 4 years. So this is year 1, year 2, year 3, year 4. So now all we need to do is put that into the calculator. It's really important in the exam that you write down that calculation. Don't just jump straight to the answer. 4928 and 50p. And again, I've ignored everything after the 0 because we're talking about money. Right, second question. This time Jill invests £3,500 in a savings account. The savings account pays compound interest of 3.2% in the first year and 2.6% in the second and the third years. Calculate how much money Jill will have after 3 years. So we've got a slightly different situation now where Jill is getting different interest in the first year and then the second and third years. Now this is a common thing that happens with banks, is they'll pay you more interest in the first year to try and entice you into going with their bank, and then that interest rate will lower in the second, third, fourth years, etc. So pause the video, have a go at that question. So Jill invests £3,500. She's getting 3.2% interest in the first year. So let's work out my interest in the first year. So 100% plus 3.2. So that means Jill's going to have 103.2%. As a multiplier, that's 1.032. Now, if that interest rate was the same, we'd just keep multiplying by that 1.032. But as we've seen in the second and third years, her interest rate is changing. So she's now only getting 2.6%. So my multiplier is going to be different in the second and the third year. So in year 2 and year 3, my multiplier would be 1.026. Again, really important in the exam that you put this level of working out down, helps you to break down your thoughts, minimises the chance of you making a mistake. So we've got 3,500 multiplied by 1.032, that's my first year, multiplied by that by 1.026, and then multiply that again by 1.026 for the third year. So work that out. Again, be really careful with your calculations. £3,802 27p. Because it was 265, I've rounded that 6 up to a 7. Finally then, let's finish with an exam question. So pause the video, have a go at this question. Alright, let's have a look, see how we did. So Joan invests £6,000, so that's pretty crucial, so I'm going to highlight that. The savings account pays compound interest of 2.4% interest in the first year and 1.7% interest for each extra year. So that means the second year, the third year, the fourth year, the fifth year. Calculate the value of Joan's investment after 3 years. So again, first step is to work out my multipliers. So if she starts with 100% and she increases by 2.4%, that's 102.4. So my multiplier is 1.024. That's the first year. The second year, well, this time we're adding on 1.7%. So that's 101.7%. So my multiplier is 1.017. Really important we get that right. If we don't get that right, we're not going to get this question correct. So £6,000 multiplied by 1.024, so that would give me year 1. Multiply that by 1.017 and then multiply that again by 1.017, because the question asked for 3 years, so in the second and third year she's getting 1.7% interest. Again, be really careful putting that into your calculator. So we've got £6,354.67p. Again, I've ignored everything after the 7. Right, let's just look at a mark scheme for that. So this is a typical 3-mark question. So you would get 1 mark in the exam if you've increased 6,000 by 2.4%. So if the examiner can see a method for increasing by 2.4%, maybe using the multiplier 1.024, you're going to get your first mark for that. If you then understood the question successfully and you've realized that we've now got to increase it by 1.017 and then by 1.017 again, then that would give you the second mark, and then the third mark is for the final answer. So 3 marks wasn't a great deal of work. It's about right for the amount of work that we had to put in. As long as you understand this idea of using a decimal multiplier, then that question is definitely accessible to all. Now again, this question could appear on both the higher paper and the foundation paper. The higher paper, you're going to see that question in the first sort of third of the paper. The foundation paper, that's going to be towards the back end. Okay, thanks for listening. Hope that's made sense. If there's anything there you're not sure of, if you maybe didn't get those questions right, don't forget you can come back at any point and watch this video again.